Good morning, my dear friends. Today, uh, I have bring a new video on one of the important topics in designer X-Men, that is missing plot technique. So, missing plot generally arises in design when, due to some reason, observation could not be recorded due to some external factors, internal factors, and it generally arised in field experiments. So in my earlier videos also I have discussed some of the field experiments like randomized block design, Latin square design. So in such experiments, designing such experiments, we could encounter some of the missing plots. Then when such situation arises, how we can deal with such problems and analyze the data. For this we have certain kind of formulas and certain procedures to be followed in missing plot technique. So my first slide is the introduction. For valid use of the analysis of variance technique, the basic data should be satisfy certain conditions. First, the data should conform to the assumptions of analysis of variance. Secondly, the observations from all experimental units should be available. In case of failure of the first condition, we resorted to transformation of data. If the second condition is not satisfied, when we use missing plot technique. So in this slide, it has been said that we all know there are certain assumptions of analysis of variance because all the models of design experiments are based on these assumptions only. And as I have already mentioned, if the experimental units or observations are not available for certain plots, we have to use this technique. Sometimes the observation from certain experimental units may be missing due to various reasons. For example, the plants in a plot may be destroyed by straw cattle or rats or floods. The plant stands in some plots may be deficient due to poor germination or due to pest attack or due to cultural operations. In experiment or animals, an animal may die before the completion of the experiment. When measurements are made outside the field, as in case of assessment nitrogen content of plants, 1000 grain weights, leaf area, etc., some portion of the sample may be lost accidentally before the measurements are taken. So these are some of the reasons for which we can have some of the observation missing in the experimental units. The loss of data in such cases are not due to effect of treatments, hence they are treated as missing value. If the lost data is due to effect of treatments, then it is not a missing value. Hence the estimation of missing value together with the analysis with missing value is generally referred to as missing plot technique. So these observations are not considered as loss due to some kind of treatment effects. If such observations may arise where the experimental unit is not giving any output due to the treatment, then it will not be considered as missing. Then we have to deal with it differently. The missing values are estimated using the method developed by Yates. The estimated values are entered in the body of the data. The analysis of variance is then carried out as usual. However, some modifications have to be made in the analysis of variance table. There are certain modifications that has to be made while using this technique. The first modification is the correction of treatment sum square. Usually the estimated missing value will be positively biased. Hence the treatment sum square is biased upward. The amount of bias in treatment sum square can be found out by using appropriate formula. The estimated bias has to be subtracted from the actual treatment sum square to get the corrected treatment sum square. The estimation of bias is done only in case of one missing value. If more than one missing values are there, the treatment sum of square is corrected by some other method. So in case of one missing value, the treatment sum of square, which is calculated from the treatments, should be corrected. Secondly, the error degrees of freedom is corrected. If one value is missing, 1 degrees of freedom is subtracted from the error degrees of freedom. In general, if small k values are missing, k degrees of freedom are to be subtracted from the error degrees of freedom. This is because the estimated values do not contribute to the error sums of square. So we have gone through our ANOVA table. We know we have different types of sums of square, and one of the important sums of square is our error sums of square. But in case of missing value, if we have in RBD only, if we have 10 treatments and 3 application, then our error sums of square should be t minus 1 and small r minus 1, that is 9, 18. But when we'll be using this missing plot technique, our final ANOVA table will be having 17 degrees of freedom. We have to deduct 1 degrees of freedom for the error sums of square, because that value is not contributing to the calculation for error sums of square. Thirdly, the standard error formula for the difference between the mean of a treatment with missing value and that of any other treatment is different from the usual formula. So from this analysis also we calculate standard error of difference, which help us to calculate the critical difference value, and also standard error of mean also could be calculated from this analysis. But the formulas are a little bit different in case of missing plot technique. Now first we will be observing about the missing plot technique of RBD. Here is the formula. With a single missing value in RBD with small t treatments and r application each, the first step is to estimate the missing values by using the formula. So this is the formula, where capital X is the estimate of the missing value. Capital R is the total of the available values of the replication that contains the missing value. Capital T is the total of available values of the treatment that contains the missing value. G is the grand total of all available values. Here the treatment sums of square is to be corrected by subtracting the upward bias from it. Now we have a formula for upward bias also. This is the formula for upward bias, and is given by capital bracket, second bracket, capital R minus t minus 1 into capital X whole square, and in the denominator it is small t minus 1. The degrees of freedom of error is corrected by subtracting 1 from the actual degrees of freedom. This is because the estimate value do not contribute to the error sums of square. Now there is another formula for missing plot technique in LSD, that is Latin square design. So we know in Latin square design we have different sources of variation, one due to treatment, one due to rows, one due to columns, one due to errors. So these are the certain kind of notations is there in the formula. That is capital R stand for row total containing the missing value, capital C stand for column total containing the missing value, and capital T stand for treatment total containing the missing value, and capital G, that is the grand total of all the values. Here also we have to calculate the upward bias, and we have to deduct it from the treatment sums of square. In missing plot technique for LSD, the degrees of freedom for error is corrected by subtracting 1 from the actual degrees of freedom. This is because the estimated values do not contribute to the error sums of square. This same step is followed for LSD, just like our RBD design. This was a short video regarding the missing plot technique, and it has been discussed both for RBD and LSD. In upcoming days, we will be discussing some of the problems regarding this missing plot technique. Thank you all.